Assalamualaikum warahmatullahi wabarakatuh. Today, we want to present for the assessment for this subject of modeling and computer analysis BMMA 2353. So the assessment is PBL F1 in school. So our group is group S3B. So the name of our company is HanPin Sdn Bhd. So this is the company team's members. So first, I am as the CEO, Muhammad JEFFRI bin SUFYAN. And then our second members is Muhammad NABIL bin Muhammad HUSAINI. And third members is Muhammad Alif Haikal bin AZAHARI. And the fourth members is Muhammad HAFIZIN ARIF bin TAJUDIN. And the last is Muhammad HARITH bin MAJID. Okay, next. Okay, so this is the company profile. So company name is HanPin Sdn Bhd. Company core business is quality, precise, safe in model design development. So our mission is to grow and create value by supplying innovative product automobile and technologies for maximum customer safety, satisfaction and convenience with due respect to legitimate interests of all categories and regulative. So this is our mission, and then our vision is to conquer the market in providing safety and comfort in automobile industries. Okay, next our organization chart. So first I am Muhammad Jeffrey bin Sufyan as a Chief Executive Officer, and then Muhammad Nabil bin Muhammad Husaini, Executive Assistant and Secretary, and then Muhammad Alif Haikal bin Azhari, Chief Research Officer, and Muhammad Hafizin Arif bin Tajudin, Chief Engineer and Design, and last is Muhammad Harith bin Majid, Chief Operating Officer. So this is the our organization chart. Next, this is the project time plan for this project, this assessment, PBL assessment. For April week 5, week 6, week 7, and in April. So first we do meeting for profile company, discussion for project, background and job distribution, design idea and design process, plus final selection. And then on May we do two activities. First activities is design idea, we continue design idea and design process final selection, and then product development and evaluation of function and cost. So this activity will continue until week 12 in June also, and then for week 13 discussion on the product structure possible improvement and final conclusion of the product, and last final report writing, design review CAD modeling and presentation. So this is our project time plan. Next, company team job scope. So our job scope, me as a chief executive officer, managing the overall operation and acting as the main point of communication between company members. And second, executive assistant and secretary Muhammad Nabil, drafting the project's report and ensuring that report are made available according to the project progression. And the third, Muhammad Alif Haikal as a chief research officer, establish and execute the overall vision and strategy for the firm while also overseeing the project. And fourth is Chief Engineering and Design Muhammad Fizin Arif, study, research and develop ideas for the project progression to increase efficiency or improve performance of the company and the team members. Chief Operating Officer Muhammad Harith bin Majid, assisting company members in overseeing the project while also gathering drawing and specification, calculation, material and equipment requirement, and setting up product method. Okay, chapter 1 for our project is introduction and background theory week. Week 6. So project title is F1 in school, objective to enhance the design performance of the automobile model. Second is to improve the design structure and components integrability. Third is to improve the overall safety factor of the automobile model. And the problem statement is Bakika design that affect the aerodynamic factor, improper weight distribution that affect properly force, and third, material does not withstand slight impact when of course and crashing. Scope project focus. This project is comparison of improvement the overall design performance of the automobile F4 model by implementing a new design structure and the ability of each component assembly. So this project will study the modelization, generative structure analysis, and determine the safety factor of this model. Okay, next chapter 2 design process, week 7 until 8. So this is the main body. The main body is the largest component of this model. It is a single piece of F1 model block material existing rear of the front axle, center line, and serve as a housing for both the virtual cargo and compressed air cartridge chamber, and situated at the end of the main body. It is a cylindrical clear space that is used a compartment to house the air cartridge to propel the model. So at the left and right, we have a cylindrical clear space. So next, tire. The main function of the tire is to transmit acceleration and braking force and to support the whole weight of the model. Next, our front wing function as a downforce controller to the model while also controlling the whole airflow around the mode. The front will also affect the overall aerodynamic of the car as is the first part that comes with contact with the resistant rear wing. Also, a spoiler is the most common aerodynamic device that is used to scrub airflow and prevent lift. As the propel force are concentrated, the rear wing is important to keep the model wheels to the ground. And is the minor of the component iaitu is uh, rod. So as a rod or shaft that rotate the wheels and support the cars. And the bearing serve to reduce friction and allow the smoother rotation. As a shaft bearing keep the axle placed while allowing them to spin smooth and stable. So that's all. So I will pass to my friend to continue.
All right, thank you, Jeffrey. So for the chapter 3, uh, I'm going to present, and my name is Muhammad Nabil. So I'm going to present chapter 3, product development, which is the duration is from weeks 9 to until week 12. So okay, firstly, for the first one is identify product design, which as we can see from the name is to we first identify which is the design we will take, what is the relevance of the design that we will sketch. So then number 2 is specify the requirement. So after product identify product design, specify the requirement means we're gonna do what we gonna improvise the design and make suitable adjustment from the design. So we're going to take consideration in factors that we will apply into the design, and then finally, the third is the idea finalizing. We will implement it in the idea finalizing. So fourth is the develop prototype design. So in this case, we will start to sketch the prototype, and then we will continue designing from there. Then five is analyze prototype. So like I said earlier, this comprising of the step 4, which will analyze the prototype. We will continue to study whether we will need to improve the design or we will keep some of the features. And the sixth is the prototype finishing. This is the step after 5, which after analyzing prototype, we will make suitable finishing and adjustment to make it finalized for our project. So next. All right. This is the assembly view of our prototype and our final prototype. So our product name, as you can see here, is the Mighty Flash. So it have quite a few parts here. So we can move on to the next slide. Jeffrey, next. So this is the main body. All right. Next. Okay, this is the front wing. Next. All right, this is the rear wing. Next. This is the rim tire. Next. All right, this is the tire, the rubber one, of course. And this is the axle rod, which will hold the tire together. And this is the next bearing, which will ensure that the rotation of the axle will continue to stable and smooth during the model is moving. So next is the discussion. So as we can see here, there are several improvisations that we had altered and added to our design when we compare to the base design that is provided or that have become an example to our design. So one of the factors that our design has taken into consideration during the design process is aerodynamics. So aerodynamics is very important to reduce drag and to increase stability. So the main function is to reduce drag. So it will up, it will up, it will reduce air resistance when the car is moving. And to increase stability means that we will also add several features such as we we will add more downforce from the wing. So that is the role of the rear wing. So aerodynamics in F1 is centered on the production of downforce. So like I said earlier, so the downforce is the principle that is opposite from the airplane's lift, where the latter's purpose is to lift the vehicle from the ground, while the former's purpose is to keep vehicle to the ground. So F1 car creates downforce in two areas, which is the front of the car and the rear of the car. So that means the front of the car refers to the front wing and the rear of the car refers to the rear wing. So the main body also developed to have a sleek and low center of gravity front end to further improve the aerodynamic factor. So we make the design to have a sleek front and rather low to the ground, so low center of gravity. So this is to improve the aerodynamic factor and also improve the stability. So we also modified the turning vanes as to further removing drag or air resistance. So the main function of the turning vane is to divert as much air as possible from the tire to the main body and to help control the turbulent weight from the front wheels and to scavenge air from the front wing and under chassis area, turning the airflow towards the side ports, floor and diffuser. So contrary to the original purpose, so our model discards most of this function as we determine that it is not necessary on a scale down model. So when the model is moving, so the air is not as the property of the air resistance is not the same as a real life F1 race. So we discard most of those function. So next is that's all from me. So I pass to the next member.
Okay, hello. My name is Muhammad Haris bin Majid. Okay, today I would like to present about part material. Okay, now one is part body. We use material ABS plastic. Number two, part rim, tire. We use ABS plastic also. Number three, rear and front wing. Also, we use ABS plastic for the material. And number four is tire. We use rubber. And number five is drive shaft bearing. So we use ABS steel. Number six, we use drive shaft. Also ABS steel. Number seven is chamber. Chamber is material ABS plastic. Next, Jeffrey. Okay, this is the product specification. Okay, first, this is the isometric view. So product specification, the product name is Mighty Flash. Total weight is 253.982 gram. Total volume is 2.083. Exponent -0.004 meter per cube. Okay, center of gravity also, which is from X is 42.611 millimeter, Y is 4.111 millimeter, and Z is 15.003 millimeter. Okay, next. So here is the cost and calculation. So for the main body, quantity is 1, tire, the quantity is 4, rear wing, the quantity is 1, front wing, the quantity is also 1, rim tire, the quantity is 4, drive shaft, the quantity is 2, and for the drive shaft bearing, we use the quantity is 4. So here is the assembly information. So assembly name is Mighty Flash, date and time of report is 28 June 2021. The total weight is 253.982 gram. So the total number of assemblies is 1, lot size also 1. So we estimated cost per assembly is 300 ringgit. So here is for the purchase part is, so For the total calculated part is 295 ringgit, which is 70% from our product, and the purchase part is 0 and 0%. Toolbox part is 0 ringgit and also 0%. Operations, we provided 122 ringgit, which is provided 30% for our product, and markup is 0 ringgit and also 0%. Okay, for the component cost impact, so the main body material cost is 27 ringgit per assembly, 15 ringgit also for the manufacturing cost, and the total cost is 42 ringgit. Tire is 25 ringgit, 12 ringgit for the manufacturing cost, and total is 37 ringgit. Rear wing is 80 ringgit material cost, manufacturing cost is 70 ringgit, and total is 35 ringgit. For the front wing, material cost is 10 ringgit, manufacturing cost is 60 ringgit, and the total is 26. And for the rim tire, material cost is 30 ringgit, manufacturing cost is 10 ringgit, and for the total cost is 23 ringgit. Drive shaft is 40 ringgit for the material cost, manufacturing cost is 9 ringgit, and the total cost is 23 ringgit. For the axle shaft bearing, material cost is 50 ringgit, manufacturing cost is 10 ringgit, and the total cost is 25 ringgit. So the total cost for material cost is 122 ringgit, manufacturing cost is 89 ringgit, and the total cost for this total is 201 ringgit. And for the cost breakdown for each part, so the total of each part cost is 122 ringgit, and the total cost is 295 ringgit. So we just multiply each type of part body and the quantity. Okay, next step. Okay, chapter 4 I will pass to Muhammad Hafizin Arif.
Hello, Assalamualaikum. My name is Muhammad Hafizin Arif, and I will discuss about finite element analysis (FEA) of this project. The finite element analysis (FEA) is the simulation of any given physical phenomenon using the numerical technique called finite element method (FEM). FEA software is also to reduce the number of physical prototypes and experiments, and also to optimize components. We have conduct FEA to our F1 model part by part, and the first one is von Mises analysis. The purpose of von Mises stress is to determine if the material can sustain the given load, to determine either the material will yield or fracture after the exposed to the certain load, the focus point of the stress on the middle of the product, and lastly, will produce the reaction from the fixed and supported component. Second analysis of FEA is displacement. Displacement defined as the movement of individual point on the structural system due to various external load. It is to determine the forces on the structure by applying on the equation of equilibrium. The analysis of deformation can determine stresses and consequently forces. From our observation, the displacement will not affect the function of the product. It is also will not cause the material to fracture, which is still in elasticity phase since the von Mises stress is still below the yielding stress. Displacement can happen during the analysis, also will not change the product design, and it will turn back into the original position. Displacement result is very important for the research and development purpose in order to reduce cost and find the suitable material for the suit application. Next step. And the third is deformation analysis. Deformation will happen when a load of force applied to the structure of the material and causes that particular material to change the shape. This process is called as deformation. There are many types of deformation, which is elastic deformation, where it happens temporarily changes the shape and return into the original shape after the load of the force is removed. Plastic deformation, which is changes the shape permanently after the maximum load or forces that applied on the product. During the deformation, the material that has been tested need to pass through 3 successive stages of deformation by increasing the stress of the force applied to the product. First and foremost, this product will go elastic deformation where the strain reversible. Then it will undergo to plastic deformation where the strain is irreversible, and finally at the fracture stage. Okay, now I will present the von Mises stress displacement and deformation analysis result by part by part. And the first part is the main body. To set up the analysis, we clamp at each axial hole and apply 2000 Newton force at the top center of the main body, and the volume and the value of maximum von Mises we get is 12.7 megapascal. Next. Okay. Next is the rim wheel analysis. We claim the area is inside the rim axial hole and apply pressure of 0.005 megapascal at outside of the rim, and the maximum value of von Mises stress we get is 0.00477 megapascal. The next is the front wing part, where we apply the force of 2000 Newton on top of the front wing area, and the value of max von Mises stress is 686 megapascal. Next is the rear wing analysis, where we also apply the force of 2000 Newton at the top surface area, and the value of maximum von Mises stress is 759 megapascal. Okay. Next is the tire part analysis. We apply 0.005 megapascal pressure at the outside of the tire, and the maximum value of von Mises stress is 0.00077 megapascal. Okay, next is the axial shaft part analysis, which we clamp at each end of the shaft and apply 2000 Newton of force on top of the axial shaft. So the maximum value of von Mises stress we get is 496 megapascal. Lastly, the axial shaft bearing, which also we apply force of 2000 Newton megapascal. We apply force of 2000 Newton pascal, and the maximum value of von Mises stress is 620 megapascal. Okay, that's all from me. Next I will continue with Muhammad Alif Haikal.
Thank you, Muhammad Hafizin. Okay, my name is Muhammad Alif Haikal bin AZAHARI. I will explain the discussion on techniques to improve design failure during analysis. Okay, during the analysis, there are some failures that can occur caused by some of the character mistake on the product. However, this failure can be solved by doing some modification on the parts that influence the failure, such as the material. We can use stronger and durability material, but need to be remember the material weight must be suitable for this product. The material also must be easier to use during the manufacturing process and cost effective, because the price must be relevant with before. If the failure happens caused by the improper dimension of product, we can adjust the dimension until it can support the load, but the dimension also need to follow the specification of this product as it can be suitable to use. Finally, we can also improve the F1 product by making a modification on the parts, like upgrade some of the other parts with durable material which able to sustain the load of force to avoid permanent deformation, which is a plastic deformation. Okay, for factor of safety, yield strength for material, ABS plastic, we get 16.5 megapascal. Next, for silicon rubber, 145 megapascal. For steel, 250 megapascal. Then distributed forces is 2000 Newton, while pressure is 0.0005 megapascal. Okay, next for von Mises stress for main body, we get 12.7 megapascal. Tire 0.000677 megapascal. For rear wing 759 megapascal. And for front wing 686 megapascal. The rim tire 0.00477 megapascal. And the next one is drive shaft is 496 megapascal, and drive shaft bearing is 620 megapascal. Okay, for factor of safety, ultimate stress or actual stress, factor of safety is a ratio between strength over stress. If the material strength is so high and stress is so low, the factor of safety will be high. Over ratio of factor of safety will be unnecessary. This will lead to material waste and unsuitable application. This make our product material is suitable for the application and will remain in shape even after the load that we determine applied on the action surface. Factor of safety is important to reduce failure during analysis and to make sure that the product will not fail during its application. Over constraint of factor of safety will cause us to use unnecessary material to the product application and also increase unnecessary costing for our manufacturing process. Okay, this is factor of safety. For main body, we get 1.299, and next one is tire 0.21 times 10 to the power of 6. Okay, other than that, for rear wing is 0.022, and next for front wing is 0.024. For rim tire 3.459 times to the 10 to the power of 3. For drive shaft is 0.504, and last but not least, for drive shaft bearing 0.403. Yeah. Okay, safety and sustainability features. Okay, by design we improve the in front and rear to increase downforce, forcing the car to stay on the ground while moving. Okay, secondly, lowering the center of gravity of the model to increase overall stability of the product. Thirdly, adjusting the weight distribution of the F1 model to be balanced on both front and rear to prevent oversteering and loss of proper force. Okay, lastly, the design of the F1 model is overhauled to implement a more robust and secure component assembly. Okay, next for biomaterial, replacing the material with a lighter but still durable alternative. And then depending on the production resources, the alternative material may be cheaper and easier to produce. Okay, lastly, the alternative material should be a good insulator and resistant to external stimuli such as heat and electricity. Okay, at the end of this project assignment, we have achieved a majority of the objectives that had been set up and have met most of the requirements that are needed in this task. We have studied and developed an improved design of F1 model to enhance the overall performance of the car. Okay, the design also introduced the new structure that enhances the robustness of components assembly and making it more secure. The safety factor of the model has also been improved in terms of material and design. As based on real event F1 in school, all the main compulsory specifications are adhered according to the event regulation. In this assignment, after done developing the design and FEA von Mises stress analysis conducted to study the force that our model can withstand before it is deformed. We had learned a lot from this assignment, such as project management and design development. We also had improved our skills in CATIA V5 and had learned quite a few tricks during this assignment production. And last but not least, this assignment project is very effective in developing our creativity innovativeness, and preparing ourselves to be an excellent technologist in the future that is well versed in automotive designing. That's all from Group 3 SB. Thank you.